Hello everyone, this is M. Niranjana from first MSc Physics at Hindustan College of Arts and Science. I am here to present about the topic Maxwell's equation in covariance for tensor form. So as Monisha explained before, summation V is equal to 1 up to 4, dou nu V by dou xV is equal to nu 0 j nu. With the above definition of f nu v, for example, if nu is equal to 1, equation B becomes dou f1v by dou fxv is equal to nu 0 j1. Then dou f11 by dou x1 plus dou f12 by dou x2 plus dou f13 by dou x3 plus dou f14 by dou x4 is equal to nu 0 j1. So 0 plus dou b3 by dou x2 minus dou b2 by dou x3 plus dou into minus I by c e1 by dou into ict is equal to nu 0 j1. Then curl b minus 1 by c square into dou e1 by dou t is equal to nu 0 dou 1, which is equation number 9. If nu is equal to 4, equation A becomes dou f4 v by dou xv is equal to nu 0 j4. Then dou f41 by dou x1 plus dou f42 by dou x2 plus dou f43 by dou x3 plus dou f44 by dou x4 is equal to nu 0 j4. So dou by dou x1 into I by c e1 plus dou by dou x2 into I by c e2 plus dou by dou x3 into I by c e3 plus 0 is equal to nu 0 j4. Then dou e1 by dou x1 plus dou e2 by dou x2 plus dou e3 by dou x3 is equal to nu 0 c by I into I rho c is equal to rho by omega 0 into nu 0 c square, which is equal to 1 by epsilon 0. Let's take this as equation number 12. Similarly, for u is equal to 2 and 3, we will get equations 13 and 11 respectively. Now consider the equation 8 and 6, which in terms of components can be written as 0 plus dou e3 by dou x2 minus dou e2 by dou x3 plus ic into dou b1 by dou x4 is equal to 0, which is equation number 13. Then dou e2 by dou x1 plus 0 plus dou e1 by dou x3 plus ic dou b2 by dou x4 is equal to 0, which is equation number 14. Similarly, dou e2 by dou x1 minus dou e1 by dou x2 plus 0 plus ic into dou b3 by dou x4 is equal to 0, which is equation number 15. Similarly, ic into dou b1 by dou x1 plus ic into dou b2 by dou x2 plus ic into dou b3 by dou x3 plus 0 is equal to 0, which is equation number 16. Dividing this equation by ic, we get 0 minus I by c dou e3 by dou x2 plus I by c dou e2 by dou x3 plus dou b1 by dou x4, which is equal to 0. Then I by c into dou e3 by dou x4 plus 0 minus I by c into dou e1 by dou x3 plus dou b2 by dou x4 is equal to 0. Similarly, minus I by c into dou e2 by dou x1 plus I by c into dou e1 by dou x2 plus 0 plus dou b3 by dou x4 is equal to 0. Then dou b1 by dou x1 plus dou b2 by dou x2 plus dou b3 by dou x3 plus 0 is equal to 0. New sign f nu v, these equations can be written as 0 plus dou f34 by dou x2 plus dou f24 by dou x3 plus dou f23 by dou x4 is equal to 0, which is equation number 16. dou f43 by dou x1 plus 0 plus dou f14 by dou x3 plus dou f31 by dou x4 is equal to 0, which is equation number 18. Similarly, dou f24 by dou x1 plus dou 41 by dou x2 plus 0 plus dou f21 by dou x4 is equal to 0, which is equation number 19. Then dou f23 by dou x1 plus dou f31 by dou x2 plus dou f12 by dou x3 plus 0 is equal to 0, which is equation number 20. All these equations 17, 18, 19, 20 can be written more compactly in a single equation. That is dou f lambda nu by dou xv plus dou f nu v by dou x lambda plus dou f v lambda by dou f nu, which is equal to 0. Let's take this as equation number C. In the above equation, if we choose lambda, nu, v to any combination of 1, 2, 3, we always get dou f12 by dou x3 plus dou f23 by dou x1 plus dou f33 by dou x2 is equal to 0. Then dou b3 by dou x3 plus dou b2 by dou x2 plus dou b1 by x1 is equal to 0, which is equation number 16. If we set one of the indices lambda nu v equal to 4, then we obtain one component of curl E plus dou b by dou t, which is equal to 0. For example, let lambda is equal to 1, nu is equal to 2 and v is equal to 4. Then dou f12 by dou x4 plus dou f24 by dou x1 plus dou f41 by dou x2 is equal to 0. So, dou b3 by dou into ict plus dou into minus I by c e2 by dou x1 plus dou into minus I by c e1 by dou x2 is equal to 0. Then dou b3 by dou t plus dou e2 by dou x1 minus dou e1 by dou x2 is equal to 0. Curl e3 plus dou b3 by dou t by equal to 0, which is equation number 15. So we see that equations B and C are Maxwell's equation in terms of f nu v, which is defined by the expression A. Now, as the tensor equations are invariant under the coordinate transformation, Maxwell's equation B and C, that is 1, 2, 3, 4, are invariant. That's all about the Maxwell's equation about the covariance tensor form. Hope you all understand. Thank you.